Hello. Good morning to all the participants and Umang sir. Welcome to the third day of AICTE-ISTE sponsored online refresher program on machine learning and pattern recognition. So today, Mr. Umang Kejeriwal is with us. So I just hand over the session to Umang sir. Umang sir will carry out the session. Umang sir.
Okay, thank you so much, sir. Okay, good morning, everyone. So now today, let's start the session now. So let me share my screen. Okay.
Yes.
So today we have to learn about the image processing. How do we apply some kind of processing on image? And we will be doing one project also related to that. That will be face detection project from the image, human face detection. Okay, so that thing we are going to do today. So first of all, I'm going to tell you some overview about the image, and then we will go for the practical part. Okay, so okay, now first of all, I want to ask from you, do you know what is an image? What is actually behind an image? What is actually behind the image? Matrix, pixel, correct. Correct. See, basically, before going to that, image is of two types. Basically, we use two types. The first one is the two-dimensional image. And second one is the three-dimensional image. Two-dimensional image is known as grayscale or black and white image. Basically, it's a grayscale image or black and white image in which there are two channels, black and white. Okay, there are only two colors. Okay, in 3D image, it is a color image. And the common color image that we have is RGB. That is red, green, and blue. And we have BGR also. We have HSV also. So we have so many. But this is the most common one, RGB. I hope you must have heard about this RGB. In case of image, we call this color as a primary color, because we can make any color with the combination of these three colors. And image is what? Image are made by the colors only. If we combine different colors, then it will make an image only, right? So basically these two types of image are there. Now, if I talk about this one, I told you that there are only two layers, two channels, black and white. So the color, the pixel value, basically here, they are in the form of a matrix, or we can say that it is the form of an array. It's a form of a matrix into rows and columns, and it's a two-dimensional array, two-dimensional matrix we can say, and it contains only two color pixels, that is black and white. So here in this case, the range of the pixel values lies between 0 to 255. 0 to 255. So 0 is completely black and 255 is completely white. 255 is completely white. So that means if I increase the value of the pixel from slowly from 0 to 255, the color from black will be slowly changing into white. First of all, it will move towards gray, then towards white, slow and so on. Okay. But if I talk about this one, we have three colors, R, G, B, and all these three colors are in the range 0 to 255 separately. R will be 0 to 255, green will be 0 to 255. So that means if I take the R value as 0, G value as 0, and blue value as 0. So this which color it will be? It will be a black color. If I take 100 for R, green for 0, blue for 0. So it will be a red shade. It will be a shade of any red color. Okay. If I take 100 here in red, in green, if I am taking, in green also, if I am taking 100, so it will be a mixture of red and green. So like this, the colors are made. If you want to see, I will show you. You can see here, like this is RGB. Right now it is 255. So this is complete red. You can see if I write here, suppose 100 and here suppose 50. So the color will be somewhat like this, orange color somewhat. If I give here 50, it will be like green something. So as we are changing the color here, you can see the value of RGB is fluctuating. You can see it's changing. That is how we change, we give the colors. So combination of all these colors make a image. So am I clear? What is actually behind the image? Is this thing clear? Yeah. So basically now what we are going to do is we are going to take an image, any image we will consider, and we will convert that into image. We will convert that into, sorry, not image, we'll convert that into array or matrix, and then we will see, and we will apply some kind of processing. Processing like we will crop the image, we will resize the image, we'll change the color of the image. These are all things we are going to do now. Okay, so let's do that. So for that, I'll simply open the Google Colab. Take a new notebook file. Okay, so I will give the name of the file as SSBT. And today's date is 23rd of December. Yeah, simple image processing. Okay, so that's my file name. I'm going to share the link of this file so that if you want the code, you can get it from here. Okay, you can get the code, open the file in the new tab. Now, first of all, I will be importing the library that we need for this image processing. So the library name is CV2. CV stands for computer vision. This is the library that we will be using for the image processing. Okay. And the second one is matplotlib. This is the library that we will be using for visualizing the image. Okay. So in this matplotlib, I am importing only the pyplot class, not the complete library, because this is only be used. So I'll import this now. Okay, it's done. Now you must have any image in your laptop, any JPG or PNG image, any kind of image you must have, or if you don't have, you can download it from Google. So what I'm going to do is I'll simply click on this folder and I will upload any image here. So let's upload any image which we want to process. So let me see. Okay, let me take my image here. This is my image. So I'll take this one. I'll upload this. Click on OK. Okay, so it's uploaded now. Now, after uploading, I have to read this image using this library. So I'll write here img, that's a variable name, equal to cv2.imread. That means image read. And here you have to pass the path of the image. So I'll right click and copy path and I'll paste here. Then I'll simply print img. So you can see I am getting some kind of array. And by these three brackets, you just see that it's a three-dimensional array. And these are the 3 color pixels value. And this is a very big array. That's why we are getting some dot dot sign. That means it is skipping some part. So basically, when we read the image using this imRead function, it converts the image into BGR. That means this is the color pixel for blue, this is the color pixel for green, and this is the color pixel for red. The reason behind this, because when this library was developed, so many years back, when this library was developed, that time the camera that we were using that time, the camera captures the image into BGR. And that is why they have developed the library in that case. So this is not RGB. This is a BGR image. It has been converted into BGR. I will show you. Okay. So first of all of you, please, those who are doing practical with me, upload any image, read the image and get this array. Please do it. I am waiting. And after completing, please tell me, then I will proceed. Okay, done. So everybody has done? Anybody who is still doing? Okay, fine. Now, if I want to know the dimension of this image, So for this, I have to simply write img dot shape. So you can see it is giving me 3 values because it's a 3-dimensional array. So this is what 861 is, basically the number of rows. So number of rows means this is the height of my image. 853 is the number of columns. That means this is the width of my image. And 3 is the number of channel, that is RGB. That's 3 colors. Okay, so basically here through this we are getting the dimension of my image. So now let's visualize this image and let's see how this my real image. This is my real image. Let me open this and show it to you, which I uploaded. I have uploaded this image. Now I'll show you how this image is converted into BGR. Wait, it is coming blank. Just hold on. It is taking time. Okay, this one. So how this image looks in BGR, I will show you now. I will write here plt dot imso. That means image so. Okay. And here you will pass img and then plt dot show. So you can see this is my BGR image. The red color is completely changed in the blue shade. The red shade is changed to blue and blue shade will change to red. So you can see. So if I have to convert back this to RGB, I can write one line of code here. IMG is equal to, or you can take RGB is equal to CV2 dot CVT color. That means convert color. And here you can pass the image that you want to convert, comma, CV2 dot color underscore BGR to RGB. Now if I execute this, now let me display RGB image. So you can see now I am getting the real image, what I am getting. So is it clear? That's how you convert the image into RGB. I hope that is clear. Please do it and try in your case. Do it. Done. Okay, everybody has done. Okay. Now just suppose that I want this image into black and white. Black and white. How can you read this image in black and white? To read this image in black and white, you just have to include one parameter here, that is 0. By default, it is 1. You just have to pass here 0. Now let's see. If I write here IMG, now you can see that I am getting a different color. This is a black and white image. This is a grayscale image. But due to the BGR property, due to this matplotlib, it is not coming in actual black and white. I'll show you how you can get it actually. So if you, sorry, if you print IMG right now, you can see that I am getting a 2-dimensional array. Can you see, all of you? It's a 2-dimensional array now. It's not a 3-dimensional array. So it has converted into 2D image. So basically, if you want to actually see in the black and white format, you have to convert this into RGB again. Then only you will be able to see it actually. What I'll do is, I'll copy this line again here and display the RGB. So it will be 3-dimensional, but it will look like a black and white. See. Am I clear? That is how you can convert any image into black and white. See, basically, if you want to display black and white, then only you have to do. But if you have to keep it in black and white in 2D image, then you don't have to do this step. You have to just execute this one only. Because after doing this, it will look like black and white, but it will convert this into 3D array. See, sorry, RGB. See, 3D array. So you don't have to do that. Just remember this. Am I clear? So just for displaying, I am doing this. Okay. Now, let's take a color image. Now, next thing I'm going to tell you. Right now, you must have seen, you have seen, all of you, that the size of my image, the dimension of my image is 861, 853. So basically, you can see that here on the graph here, near about 800, you can see that is the X1, and here in the Y1 also near about 800. That is actually this much only. Okay. Now, if I have to change the dimension, I have to change the dimension of this image. I have to make it small. How can I make it small? Let's suppose I want to change this into something 300 by 250. I want the height should be 300 and the width should be 250. So how can we do that? So see, if I write here, let's do here only. I'll write here, let's suppose new image equal to cv2.resize. Resize. And here you will pass the image that you want to convert. So I want to convert the RGB image. Okay. And into what size you want to convert? I want to convert into 300, 250. So now let's see the new image. Oh, sorry, I've done opposite. This is the height, sorry, width. So I'll change this to 250, 300. Yes, so you can see. So this is the width here and this is the height here. I will write in comment width, comma, height. You can see that's how you can change the dimension of the image. And if you reduce the dimension, your quality of the image will be slightly decreased because we are compressing the image actually. So am I clear? Try this, all of you. Do it. Same person we can apply on. See, Swati, in case of video, basically in video also what we have the image frames only, na. So when you take the video, it will be converted into different image frames, and then you can apply that to the image frames, and then you can again convert that into video. So basically, there you have to do the same operation for different image in a loop. You have to convert the image into a video into different image frames, and then you can apply that to apply the operation and then convert back to video. Okay. Just do it. I'm just coming in a minute. Complete. I'm just coming.
Yes, sir. Yes, sir.
Yeah.
Uday Kumar sir, you can join us host only.
I think all of you have done. No one is responding. Okay, let's do it. The next one is to crop the image. How do we crop the image? This cropping of image here is known as ROI. That means a reason of interest, getting the interest part of the any image. So now why it is coming, just a minute. RGB. Okay, now suppose what I want here, I want to crop, wait, let me change this to, okay, I want to crop this part, the face part of my image. I want to crop just the face. So how can we do this? So you have to, if you have to crop the face, in that one simple, the concept of slicing is applicable. You have to just slice the image. So if I talk about the x-axis, let's suppose that just wait, let me clear this. Okay. Let's suppose I want this only. Okay. So if I talk about x-axis, can you tell me the approximate range of x-axis here? Approximate range where my face is lying?
400.
400 to 600. Yeah, we can say 400 to 600. And if I talk about y-axis, it is somewhat, we can say 0 to 250 or 50 to 250. I think 200 will be less. Okay, we'll try that. So this is only we have to pass. So let's do that. So what I'll do is I will write here crop image equal to RGB off. RGB off. Now here, first of all, you have to pass the range of your y-axis. So let's try for 50 to 250. 50 to 250. Okay. Then comma, you have to give the range of x. So let's take the range of x is 400 to 600. Now let's see. Can you see? I think 50 will be, 30 will be more better. 30. Yeah. And here I think if I take 230. Just a minute, Patrick, just a minute. Okay, so basically you can see that we got the cropped image, and if I reduce it more, like 420 to 580, I will be getting more cropped image. You can see. So this is how you can crop any image. Am I clear? Tell me. So try this with your image and tell me if you are able to do that. Yeah, everybody has done. Okay. Now let's suppose that after cropping this, I want to save this image. I want to save this image. So how can I save this image?
Core tech team, she was able to conceptualize software engines for various services. Software engine-based services is a current USP of Apptronix. She ensured
To save the image, I have to write here cv2 dot I am right image right, and here you have to pass the name of the image. So let's suppose the name of the image is Umang only, Umang dot j or Umang new dot jpg, because Umang is already there in my case, so it will override, otherwise it will override this. That's why I'm doing Umang underscore new dot jpg, then comma the image that you want to save. So I want to save crop image, so I will write here crop image. Now just all of you pay attention here. If I execute this code, see, it has saved the image. Now where I will get this image? Here where you have uploaded. Open these files. You can see I got here umang new.jpg. And if I download this, right click and download, I'll show you one thing which I want to explain you right now. If I open this image, can you see which color I am getting? BGR. So basically what does it mean? What do you understand with this? That means that when we execute this code, it converts the image to BGR. So basically, I'll tell you, if this image is RGB, it will convert to BGR, and if it is BGR, it will convert to RGB. So if I want the RGB image, either you don't execute this code, or you again execute this code here. Simply override this like this. Now see, now if I execute, so here you will get BGR, but when you download here, it will be RGB. See, clear? So do it now, all of you. Do it. Done. Is it completed? Okay. Now I'm going to tell you the last thing for this part. Then we will move to the face detection project. Like in that project, we'll require this: how to draw a rectangle or a square on an image. How to draw a rectangle or a square on an image. So to draw a rectangle on a square on an image, first of all, let's make a blank image. A blank white color image of size, suppose of dimension 512 cross 512. So let us suppose I want to do that. So tell me, if I have to take the image of that size 512 cross 512, is it possible to manually create an array like that? Three-dimensional array? Tell me, is it possible to manually create an array in which there will be 512 rows and 512 columns of 3 dimension? It's not possible. In that case, how can we do that? Anyone? How can we create a blank array, an image of a blank array in that case? I will use one library. Tell me, if I want a white color image, what should be the value of the pixel of that array? What should be the value? Tell me. Yeah, all the pixels should be 255, correct. So what I'm doing is, I'm writing here img is equal to np.numpy dot zeros. Do you know zero matrix? What is zero matrix? Whose all pixels are zero. That is called zero matrix. So if I write here, first of all, let me give you an example of a small. Let's suppose 10, 10, 3. See, let's take right now 3, 3, 3. You can see it has created a 3-dimensional array of 3 rows, 3 columns, and 3 values. If I take here 4, 3, that will be 4 cross 3 matrix of 3 dimension. So similarly, what we are doing is, I will write here 512, 512. So this is my dimension of the image which we are creating in 3-dimensional. Now here, all the pixel values are 0. So how can we make this to 255? Anybody? Yeah. $255 into ones, or we cannot do plus 255, 0 plus 255. Can we not do this? Yes. So if I execute this, you can see all the pixel values is converted into 255. Now, let me explain you one more thing. Let's right now keep it 0 only. Right now, okay? And let's display this image. plt.imshow. Which logic you are asking, Swati? This 255 one. np.0 is a function that generates a 0 matrix. See, I'll show you again. If I write here simple 3, 3, it will generate a 3 cross 3 0 matrix. See, 3 cross 3. If I write here 5, 3, it will generate a 5 cross 3 0 matrix. Okay. Similarly, if you write here comma 2, it will generate a 3-dimensional matrix with 2 channels. See, 2 channels. Clear? So similarly, we have taken 512, 512, 3. So that's my matrix. Is it clear now? So let's display this image. Can anybody tell me right now what is the color of my image? What is the color of my image right now? Yeah. No, only black. Because all the pixels values are 0, na? So that is black. Right? And if I change this to 255, it's showing white. But there is one problem here. I'll tell you what is that problem. Just tell me, if I give the value here as 100, in that case, what should be the color? If I give here, what should be the color in this case? Gray shade, right? I'll show you. Can you see it's a gray shade? So if I write here plus 100, it should give me the gray shade color. Now tell me, is it gray shade? Is it gray shade? It's white. So why it is giving this problem? Because if you see the pixel value, see this, and see the pixel value of this, do you find any difference? Just see this value and see this value. Any slight difference? Yeah, correct. Data type. You can see that this is a float data, 100 dot decimal. And this is what? Integer. So it should never be a float value. It should be a integer value. And if I scroll down, you can see what is the data type of this? Unsigned integer 8-bit. So you have to take this data type. So what I'll do is, I'll simply write here here by giving comma np dot uint unsigned integer 8-bit. And now see. Now can you see I'm getting a gray shade? If I give 50, I will give another color. See, I'll get another color. What happened? Oh. See, if I write it 200, it is somewhat in white. 255, complete white. See. And if you see the pixel value, it will be integer. See. So I hope this is clear. So please do it. Collab link is not saved access. Let me check. Achha, okay. Now open that. I'm giving the link again. Now open it. So there's some good resource for learning Python. Swati, today, remind me at the end, I will upload one book of Python, one PDF book on Google Drive. You can get it from there. Okay. Whose mic is on mute? Okay, so have you all created the image? Can we continue? Okay, so now suppose if I have to draw a rectangle on this image. How can we do this? CV2 dot I rectangle. CV2 dot rectangle. Now here, just tell me all of you, what is the minimum number of points required to draw a rectangle? Minimum number of points I'm asking. 4. If we have less than 4, we cannot draw. Yeah, 2, correct. We can draw by 2 points also. If you don't know, I'll tell you how. Just tell me, if we have these 2 points, can we not draw the rectangle with these 2 points? If we have these 2 points can be calculated. Tell me. Yeah. So by 2 diagonal points, we can draw the rectangle. So in this function, we just have to pass these 2 points. Okay. So I'll write here the name of the image on which we want to draw. I will write here IMG. Then comma the first point. Let's take the first point as 50, 100. And the second coordinate as suppose 400, 100. That's the second point. Then the fourth parameter is the color, that which color you want. So for the color, you have to give it in this format. RGB. So if I give here RGB format in bracket, suppose I want the complete red color. So I will give this one as 255, 0, 0. That is completely red. And then the thickness of the line. So let's suppose I want the thickness as 4 or 5. Now let's see. Just a minute. Okay, I've given here y-axis. Okay. So that's my square or rectangle. Am I clear? Is this thing clear? Now one more thing. If I give here -1 in place of thickness, if I write here -1, it will fill the rectangle with that color. See. So please complete this, all of you. After completing, tell me. Completed? Okay. Now let's move to our project that we have to do in this. What we are going to do, we are going to detect automatically the human face in a image. Let's suppose that there are so many faces here. I want to detect the face of all these persons. And after detecting the face, I want to draw the rectangle on each face. This is the same concept when you open the camera in your phone. You must have noticed that it draws a square or a rectangle around your face. Have you seen that? Open the camera, it draw a rectangle around your face. So this is what we are going to do now in the case of image. So for this, we will use one library, or we can say a classifier that is known as Haar Cascade classifier. That is actually a pre-trained model in which like so many faces have been trained, and according to that training, it detects the human face. So this is Haar Cascade classifier. It's a predefined classifier, pre-trained. Already someone has trained this and created that model, created that library. So we are going to use that library for this detection of face. Similarly, we have the library for detection of eye, for detection of smile, for detection of upper body, lower body, full body. So we have these libraries. Okay. So we will right now do it for face. So if we have to do it for face, I'm going to share that library with you. Okay. And I'm going to share this image also with you for the practice. So download this image and that library. Just a minute. I will upload it for eye also. And smile. All of you do one thing. Kindly open the link I am sharing on the chat and download these files. Right now, you can download the face.xml, which is face.xml is not uploaded. Wait. Why it is coming 2 times? Huh? Yeah. Right now, it's required face.xml and face.jpg. You can download all the files also. So I'm sharing the link on the chat. Kindly download it in your system. Okay, please download. Please download. I'm just coming. Okay, so have you all downloaded? Okay, so now upload these files in the Google Colab. So let me upload this file here. I'll upload right now face.xml and face.jpg. Face.xml is my library that we are going to use, and face.jpg is my image on which I will be detecting the face. And this XML file is not only for this image, you can use it for any image.
So please share collab it not access.
Okay, so I've uploaded the files. Now, first of all, let's read the image. Okay, so that's my image here I've taken, and I will be detecting the face from this image. Okay, so now please all of you read the image first. Do it fast. I hope all of you have done. Okay, so now we are going to detect the face. So to detect the face, what I'll do is, first of all, I will be creating the object for the Har cascade classifier. So I will write here face underscore cascade. That's a variable only. Okay. Equal to CV2 dot cascade classifier, and here you will pass the link of your XML file. That's my file. I'll copy the path and pass it here. So that's my link of the XML file. Okay. So now this is basically an object for the Har cascade classifier, which will be detecting the face. Now this cascade classifier is not only for face. It can be for any kind of feature. It can be for smile. It can be for eyes. Just it will depend on the XML file that you are using here. If I'm using it for face, it will be working for face. Now, after this, now let's detect the face. So I will take a variable faces is equal to face underscore cascade dot detect multiscale. And here you pass the image that we want to detect. Now let's print the faces and see what I'm getting. Detect multi. Achha, S is capital here. Okay, so you can see that I am getting an array with 16 elements. 1, 2, 3, 4, 5, 6, not 16, 12. 7, 8, 9, 10, 11, 12. So why we got 12? Because there are total 12 faces. You can see. So it has detected 12 faces. Now what is these 4 values here? What is this 4 value? Now I'm going to explain you what is this 4 values here. See, if this is a square or a rectangle, suppose, if I consider this image 42, 46, so this point is this point is 42, 46. This one is happening. 42, 46. This one. What is this? Okay, wait. It is not working properly. (42, 46, 165, 165). Yeah. So your this point is 42, 46. Okay. And what will be this point? This point is, so basically, if you consider this as x, this as y, so this is your width and this is your height. So that's your 165, and this is also 165. So what will be this point called? 42 plus 165, comma 46 plus 165. Tell me, am I right? If this is your x and y, this will be your x plus w, comma y plus h. So if I am getting this point, can we draw the rectangle with these 2 points on each faces one by one? Yeah. So let's draw it. So using the loop, we will draw the faces. Sorry, draw the rectangles. So let's draw it. So for x, comma y, comma w, comma h in faces, I've taken here 4 variables because it is returning 4 data. So cv2 dot rectangle RGB. I have to draw the image on a rectangle on RGB image, comma, the first point will be your x comma y, and second point will be your x plus w comma y plus h. Let's give the color as red color and thickness as suppose 3. So now let's see what I am getting. So can you see, all of you? It has drawn a rectangle on each face. See? Yeah. And if I consider umang.jpg, see, it has drawn the rectangle here. So it will work for any image. I hope this is clear. Yeah. Is this thing clear? So please do it, all of you. Do it and draw. And if you are getting any problem, then tell me. So some participants. Yes, sir. Yes. Okay, sir.
Okay.
It will be done. Okay. Done. Okay. Now the last thing in this, I'll tell you about the eye detection. If you have to detect the eye or smile, so I will tell you about the eye part, and the smile part you have to try on your own because the same concept is there. Can you explain the argument you pass for the rectangle? This is the image name on which we are drawing the rectangle. Okay. This is the first diagonal point of the rectangle. This is the second diagonal point. This is the color of the rectangle lines, and this is the thickness of the rectangle. Am I clear, Visalini? Okay. Okay. Now, just tell me, all of you, what will be the better step to detect the face from the eye, or sorry, to detect the eye from the face, or to detect the eye from the complete image? Which will be the precise step? Yeah, to detect it from the face. Okay. So what I'll do is, first of all, I will upload the i.xml file, i.xml, through which I will be detecting the eye. And now, how to detect the eye? First of all, I'll create the same cascade for the eye. I'll write here eye cascade. Okay. Now this part will be done inside the loop, because one by one I will be picking the face and I will be detecting the eye. So if I need only the face part, how can I get? Can we get like this? RGB of y to y plus h, comma, x to x plus w, that I explained in the cropping. Tell me, I hope this is clear. Here I am cropping the face part in this single face variable, through which I will be detecting the eyes. Am I clear this one? Yeah. Now here I will write eyes is equal to I underscore cascade, and in place of img I will pass here single face. So one by one all the faces will be passed, and through which the eyes will be detected. And same thing, same loop will be there for eye also, because there are two eyes, ex, ey, ew, eh in eyes. So here I will pass single face, because I have to draw on single face. And let's change the color to blue. Now let's see. Now can you see the eyes are detected and drawn? But there are some problems also. What is the problem? Here you can see that this third girl in the third row, her nose and mouth is detected as eye. In the fourth also. And in the second row, one eye is not detected. But this is not a problem, because this girl has turned her face. So obviously, if I turn my face, obviously the eye will not be detected. Am I right? If I'll not show my eye, how my eye will be detected? So this is not a problem. But these two things, they are the problem. So how can you solve this problem? To solve this problem, we have one more parameter here in the detect multiscale, and that parameter is known as scaling factor. Scaling factor means that you reduce the pixel value, and if you reduce the pixel value, you basically through that the accuracy increase. So if I write here 1.1, this means that I am reducing the pixel value by 10%. If I write 1.2, that means 20%. So let's try with 1.1 and let's see, do we see any change? No change. Let's try it 1.15. Quite a little change we have seen. Let's try it 1.20. So slowly you have to increase and check till you get the maximum accuracy. You can see the third error is gone. Now we are just in the fourth row. So I think I remember in 1.18 it was good. No, still we are having. So 1.25. Still 0.22. Okay, so one error is there. 1.23. No, the error is increasing. So if it is increasing, so we cannot go more beyond that. 1.19. 2 errors, 3 errors. Okay, so I think 22 was the maximum. So this is the maximum accuracy that we can achieve here. Okay. Am I clear? That's how you can detect the eye, and in a similar way you can detect the smile also. So do it, all of you. Complete this, and that's all for this image processing part. That's all for this today's session. Now please complete this, and if you have any query, any doubt, you can ask me. And at 12:15 this session will end, so you all join the session again because there are some connection problem. So all of you just join it immediately for the next session at 12:15 when we will end the session. Okay. Yeah, I hope it's completed. This is the Python book I was talking about. Okay. You can get all the files from here. Okay. Okay, sir. I think they don't have any doubts.
Okay. No problem then. I think over हो गया सर.
Can you hear me, sir?
Okay. ठीक है. Over. No problem. हेलो. आवाज आ रहा है सर मेरा? हेलो. हेलो. हेलो.
Pankaj sir, are you there?
हाँ, yes. Can you listen me?
Yes, sir.
हाँ, yes. ओके सर, तो टर्मिनेट करना सर अभी. ओके.
हाँ सर. ओके सर. तो सर मैं चल जाऊँ ना फिर?
ओके, नो प्रॉब्लम. थैंक यू उमंग सर.
Okay, sir. Okay, sir. Bye, everyone. We will meet tomorrow. Okay.
या
Okay, sir. Okay, bye, sir.
या सभी पार्टिसिपेंट्स को एक रिक्वेस्ट है, सभी लोग 2 मिनट के बाद फिर से रीज्वाइन करिए. कैसा कि बहुत सारे जो पार्टिसिपेंट्स है वह अभी तक ज्वाइन नहीं हो सके, उनके लिए थोड़ा प्रॉब्लम आ रहा था. तो हम एक जस्ट सेशन एंड करके फिर से रीज्वाइन करिए आप प्लीज. जस्ट सेशन पूरा टर्मिनेट होगा अभी.